All right, these are some problems that you should be familiar with. If I'm trying to find the probability of getting a blue marble out of this bag, and you can see the bag has 6 blue marbles, 4 red marbles, and 2 purple marbles. And so what is the probability of getting a blue marble? Well, there are a total of how many marbles altogether? Well, there is a total of 12 marbles. And how many of them are blue? 6 of them are blue. And of course, we always reduce our fractions, so this would be 1/2. What is the probability of getting a red marble? Again, how many marbles in there altogether? There are 12. How many of them are red? 4. And then, of course, we reduce this to be 1/3. And the probability of getting a purple marble, again, 12 marbles altogether. 2 of them are purple, and we reduce this to be 1/6. And again, that should be familiar to you. But what happens when I'm asked this question? What is the probability of getting a blue marble and then a red marble? So we're talking about 2 events occurring. We're talking about compound events. And when we have compound events, these events are said to be either independent or dependent. So let's look at this situation here. A die is being rolled, and then a second die is being rolled. Does what happens with this first die have anything or any effect on what happens on the second die? No. And so the 2 events are independent because the first roll in no way changes the probability of the second roll. Compare that with this situation. A card is selected from a deck of cards, and then it is not put back. All right, so we started with 52 cards, and when I now go to collect my second card, I don't have all 52 cards in the deck, all right, because this first card was not put back. So these 2 events are dependent because the first card is removed and cannot be selected again. This affects the probability of the second draw because the sample space is reduced by 1 card. So in summary, we have some things that are always true about independent and always true about dependent. Independent, something is picked and then it is returned. Whereas for dependent, something is picked but it is kept out. You'll also find as you're calculating probabilities that with an independent probability, the denominators will stay the same. And for dependent probabilities, the denominator will decrease after each pick. For independent, item has the same probability of being picked each time. For dependent, the item has a better probability of being picked each time one is removed until you get down to the last choice. Some keywords for independent are replaced, returned, or put back. Some keywords for dependent are keep it out, do not return it, do not put it back in the bag, those sorts of things. For independent probability, there can be multiple picks as long as one item is picked at a time. For dependent probability, however, there can be multiple picks as long as one item is picked at a time. Until you get down to the very last one, and of course, then once you pick the last one, then there are no more picks. And here's a little sheet I'm going to give you in class on Tuesday, and it tells you how the probability rules for calculating independent and dependent events. For an independent event, the probability of getting A and then B would be the probability of A times the probability of B. If it's dependent events, it's similar. It's the probability of A and B would be the probability of A times, and this is read as the probability of B once A has occurred. And you can see again the definitions for independent. the outcome of the first event does not affect the outcome of the second event, and for dependent, the outcome of the first event does affect the outcome of the second event. We'll talk about conditional, mutually exclusive, and not mutually exclusive coming up in the next couple of days. We have talked about complementary events. The outcome of one event consists of all the outcomes in the sample space that are not outcomes of the other event. So let's look at some examples now. Let's do this one right here first. A jar contains 6 blue, 3 red, 5 green, and 2 yellow candies. Once a candy is drawn, it is returned to the jar. Now, the fact that it is returned to the jar should indicate to you that you have an independent event. And there are a total of 16 marbles in the bag. We want to find the probability of first picking a green and then picking a blue. Well, there are a total of 5 green marbles in the bag, and we will multiply that because this is independent events. We multiply the two probabilities together. We then, the candy is returned to the jar, so there are still 16 candies in the jar. And the probability of getting a blue then, since there are 6 blue, would be 30 over 256, which reduces to be 15 over 128. Now let's look at this example. A card is drawn from a deck of 8 cards with letters A, B, C, D, E, F, G, and H. The card is replaced and a second card is drawn. So we know we definitely have an independent event. What is the probability of getting a B and then an F? Well, how many cards are there? There's a total of 8 cards. And how many of them are B's? Well, there's only one that is a B. And then that card is replaced. And again, we're multiplying. We now go back for a second card. And again, there's still 8 cards in the stack, in the deck. And how many of them are F's? Well, one of them is an F. So the probability of getting a B and then an F would be 1 out of 64. Now let's look at some of these other possibilities. Let's look now at this example here. We're still talking about drawing cards, but this time the card is not replaced before the second card is drawn. So these are dependent events. And when we make our first selection, there are 8 cards in the deck, and one of them is a B. But now when I go back in for the second card, instead of there being 8 cards, there's only 7 cards. One of them is still an F, and now the probability of reaching in, pulling out a B, not replacing it, reaching in and pulling an F would be 1 out of 56. Now let's look at a little more difficult problem. Here we have a jar containing 6 blue, 3 red, 5 green, and 2 yellow. It's still the same one we're over here. One candy is drawn. It's eaten, so it's not replaced. Find the probability of getting 2 greens. Well, this is definitely a dependent event. And when we reach in the first time, as we said before, there are 16 candies. And how many of them are green? Well, there are 5 greens when we first pull out candy out of the bag. Now, when we go back in, there are only 15 candies left in the bag, and there are only 4 greens left in the bag. So the probability would be 20 over 240, which reduces to be 1/12. And as usual, if you have any questions, comments, anything I can help you with, please Edmodo me, text me, call me, email me, but definitely get in touch. And of course, make sure that you make a note or post saying that you have watched and understood the video. And again, it's always helpful if you didn't understand something, if you'll pass that along so I can modify my instruction for tomorrow. Hoping you're having a great weekend, and I'll see you on Tuesday.